Is my screen visible? Hello?
Yes, sir. Yes, sir. Yes, sir. It's
Okay, so today we will solve some numericals from the GATE exam which they have asked. Okay, so these are the questions. So you have to start from the first question itself. Okay, so I'll give you for every question, I'll give you 5 minutes. After that, I will discuss that question. Okay, so you can start with this question number one. I'll give you 5 minutes to solve this one, then we'll discuss.
Sir, can you make it large, please?
Okay, wait.
sir. If you put full slide, then it would be large, sir. Or zoom.
Is it good now?
Two, 2624. First one.
Yeah, it is right. Wait for the others to get the answer and write the answer. So solve it. Now we will solve the answer. So, 624. They have asked up to two decimals, so you have to put.
Point
put
37.
yeah.
37.
Anyone else who has got the answer?
Same answer, sir.
Who have got two students? So this question was asked in gate 2022 202.
Yes, sir.
You have also got solve
Yes, sir.
solve this question for the other students. So what they have actually given, first one, they have given that the work done. First, we will draw the diagram, and we'll this is the computer. This is W. This is W2. Okay. So what they have given question, the question they have given that the cycle. What is the cycle is? Steam power plant initially expanded in a high pressure turbine. That steam is then reheated in a reheater and finally expanded in a low pressure turbine. The expansion work. So this is an uh, ideal that superheated reheated cycle. Okay, first it is superheated, then it is reheated again the low pressure turbine, and then after that they both the turbine work they have given, pump work also they have given, efficiency they have given, and they have asked the heat rejected in the condenser. Okay, so this they have asked. What they have given, WT1 the given data, what is the data? WT1 they have given, how much they have given WT1?
400 kilojoule.
Okay, WT2 what they have
850.
given?
Pump work 15.
Okay,
Efficiency 32.
0.3. And what they have asked, they have
Projected QR.
they have Q
R.
rejected condenser. Okay, so we know what we know that efficiency. How we can write efficiency? Efficiency is given by net work upon heat supply. Okay, so what is the efficiency they have given? First, wait. So first we will determine the net work. So what will be the net work? That is the total turbine work WT1 plus WT2. Okay, net turbine work minus pump work. Okay, so what is the turbine work they have given? 400 WT1 plus 850 for WT2, and then we have to subtract it by the pump work. So what is the value you have got for net turbine work?
1, 2, 3.
How much?
1, 2, 3, 5.
2356. Okay, 5
Kilojoule per kg.
per kg. Okay, efficiency you already know it is given 0.32. So we'll directly put, so net work 1235 divided by Q rejected. That is Q supplied, heat supplied. So what will be the heat supplied?
3859.
59.37. This also you have to take up decimal because on the question they have asked up to 2 decimal. Now again we know that efficiency is given by 1 minus Q rejected upon Q supplied. This is in the condenser. Okay, and it is used where Q is supplied in the boiler. Okay, so directly we can write QS already we have determined. So efficiency is 0.32. 1 minus Q rejected divided by Q supplied. How much we have to get? 3859.37. Okay. So what we will get the Q rejected? 2, 6, 2, 4, 5, 7. Okay, is it fine?
Sir, net heat supplied equal to net work done, sir.
Yeah.
W net equal to 2S minus QR.
Actually, your voice is very loud. I am not getting. Can you decrease the volume and then ask the question? Hello.
W net equal to heat supplied minus heat rejected.
No. I have already told you that efficiency can be written in different form, like net work upon heat supplied, or you can write 1 minus Q rejected upon Q supplied. These are different forms by which efficiency can be written, and these two forms only we have used. You can directly, instead of writing enthalpy also, now you can directly this you can do that, but because QS is not given in the question, so first we have to use this formula to get QS, and after that we have to use this formula, second one, to get this Q reject. Hello,
Yes, sir.
is it fine?
Yes, sir.
Okay, so we'll go
सर
to
आई हैव वन डाउट सर
yeah.
सर ये जो पंप वर्क है इसे भी कंसिडर करेंगे हीट रिजेक्शन में
हाँ, इसमें करना पड़ेगा क्योंकि स्टीम साइकिल के केस में पंप वर्क कम नहीं होता, कंसिडरेबल होता है, जबकि गैस टरबाइन के केस में बहुत कम होता है। मतलब उल्टा गैस टरबाइन के केस में कंसिडरेबल होता है, वहां पे कंसिडर करना पड़ता है, वहां पे कंप्रेसर वर्क बोलते हैं, उल्टा बोल दिया था थोड़ी, सॉरी। लेकिन यहाँ पे इन्होंने क्वेश्चन में दिया रखा है, तो आपको कंसिडर करना पड़ेगा। अगर नहीं
ओके
देते तो बहुत कम होता है, कई बार जैसे अभी 15 है, कई बार 1 या 2 किलो जूल पर केजी होता है, उस केस में ज्यादा फर्क नहीं डालेगा वो आंसर पे, तो उस केस में कंसीडर नहीं भी करोगे तो भी चलेगा।
ओके
लेकिन जब भी गैस टरबाइन के केस में क्वेश्चन आएगा ना, उस केस में तुमको कंप्रेसर या पंप वर्क जो रहता है वो तुमको कंसीडर करना पड़ेगा, क्योंकि वहां पे अपन वीजी लेते हैं, वीजी इंटू डीपी, तो वीजी की वैल्यू काफी हाई रहती है कंपेयर टू अपना ये स्टीम टरबाइन बीएफ, तो ये वाला वैल्यू कंसिडरेबल हाई रहता है, इसीलिए पंप या कंप्रेसर वर्क बहुत कंसिडरेबल अमाउंट रहता है इन केस ऑफ गैस टरबाइन, जब अपन गैस को कंसिडर करते हैं। तो जैसे उस केस में हमारा टरबाइन वर्क आ रहा है कुछ, मान के चलो 100 किलो जूल, तो पंप वर्क भी कुछ ना कुछ होगा 40 to 50%, जैसे 30 किलो जूल पर के जी टू 40 किलो जूल पर के जी। ओके, तो वहां पे कंसीडर करना पड़ेगा कंप्रेसर वर्क, ठीक है।
ओके सर
लेकिन यहाँ पे अगर तुमको मतलब बहुत कम वैल्यू आ रही है, 1 या 2 किलो जूल पर केजी, तो उस केस में तुम अगर नेग्लेक्ट भी कर दोगे तो आंसर पे उतना फर्क नहीं पड़ेगा, क्योंकि दे विल ऑलवेज गिव अ रेंज इन दी क्वेश्चन। लेकिन अगर जैसे इस केस में 15 किलो जूल पर केजी है, तो वो कंसिडरेबल अमाउंट है, तो तुम्हें थोड़ा कंसीडर करना पड़ेगा, क्योंकि यहाँ पे फिर तुम्हारा रेंज के बाहर जा सकता है, जैसे तुम्हारा आंसर 2021 आ सकता है, और उन्होंने रेंज अगर 2023 टू 2025 दी, तो फिर तुम्हारा आउट ऑफ रेंज चला जाएगा वो आंसर, तो तुम्हारा आंसर गलत हो सकता है। तो मोस्ट ऑफ द क्वेश्चन में ट्राई करो कि पंप वर्क भी तुम कंसीडर करो, तो तुम्हारा आंसर ऑलमोस्ट करेक्ट ही आएगा।
ओके
ओके, तो do this question number 2. I'll
सर
give
सेकंड वाले का 92.916%।
second question.
यस
हाँ सर।
How much
यस
you
सर 92.9 आ रहा है।
wait, 92.9? Yeah, it is right, or almost right.
सर थर्ड वाले का 4 kg per kilowatt
Hello,
hour।
hello. Wait for some time. Let other student also solve. कितना आ रहा था ये वाले का आंसर आप लोगों का?
92.9।
90.9. हाँ सही है. It is right. X equal to 0.93. You can also write. Take it directly. Actually, they have asked in percentage, na? So it is in percentage. So you can also write or 93%. It is almost equivalent. Okay. They have, because in the question they have round off to the nearest integer value. So 92.939 की जगह आपको 93 ही लेना है. Nearest integer 93. Okay. So this will be the correct answer. If you will write 92.9, they may reject, because in the question they have clearly mentioned round off to the nearest integer value. They don't want the answer in that point. Okay.
ओके
Like these.
सर फोर्थ वाला सी होगा.
Yeah, we'll do. Wait for the others to answer. We'll solve question line by line. If those who have solved can solve other questions also, 3 and 4. Discuss
सर
line by
वो एक बार फोटो दिखा दीजिए और दूसरे क्वेश्चनों की.
हाँ सर 3-4 कंप्लीट.
ये क्वेश्चन नंबर 5 है. इसका ये वाला
सर
पार्ट
वो
यहाँ
नीचे जो बार आ रहा है सर उसको हटा दीजिएगा थोड़ा.
इसको ऐसे ही फोटो करना पड़ेगा.
ओके सर, थैंक यू सर.
Now is it okay? Have you written the question so that I can go back, because the other student might need the data for question number.
हाँ सर, वो ले लिया क्वेश्चन.
Hello? Anyone?
Second one 93, sir. 93%.
Yeah, it is right. So anyone else who has got, or should we solve the question? Okay, so we'll solve this question now. So what they have given in the question first, that steam power plant operating on an idle reheat cycle. Okay, so the idle reheat cycle, the work output to the pump. Okay, pump work they have given. Turbine, the work output from the high pressure turbine they have given. The work output from low turbine they have given. Thermal efficiency they have given. The enthalpy of saturated liquid and saturated at condenser pressure are 200 and 600. Okay, quality of the steam. quality of the steam, the exit of check. So what they have given, it is a reheat Rankine cycle. Cycle same. Okay. Five, 6. So what they have mentioned in the question, they have given the pump work. Okay. What is the pump work they have done per kg? Okay. Now what they have given, second is turbine work 1. Turbine work 1 they have given 750 joule per kg. Similarly turbine work 2 they have given 1500 joule per kg. Okay. Now they have written that the entry to the pump, that is H5 they have given. What is the value of H5 or HF? You can also write saturated. It is entering in the form of saturated. So what will be 200 joule per kg? Thirdly, they have mentioned that what they have mentioned. Enthalpy of saturation, condenser pressure are. So value of Hg they have given at condenser. This pressure they have condenser pressure at PC they have given HF and Hg. What is 2600 kilojoule per kg? Okay. So enthalpy efficiency also they have given, that is 0.5. So they just want to know the X4 at the exit of the turbine 2. What is the quality of the steam here? There, whether it is saturated or superheated or wet, that we don't know, that we will calculate. Okay. So first we know that efficiency is given by net work output upon heat supply. Okay. So 0.5 it is given. Net work we know that turbine work 1 plus turbine work 2 minus pump work. Okay. Divided by heat supply. Okay. So directly we will write. So from here we can get the that QS is 750 plus 1500 minus 20 divided by QS. So what is the value of QS you have got?
4460.
4460.
Yeah. This is QS. Now again we know that efficiency is given by 1 minus Q rejected on Q supplied. Okay. So 0.5, 1 minus Q rejected we don't know. Q supplied is, how much is the Q supplied? 4460. So from here what will we get the Q rejected? Q rejected we will get 230
30.
kilojoule per kg. Now we know that heat rejected, that Q rejected it is in the condenser. Okay. So what is the enthalpy at the condenser? From here we can write H4 minus H5. Okay. So this we have already got 2230. H4 we don't know. H5 is equals to, or HF. It is equals to HF because it is in the we know it is mentioned in the question that steam enters the compressor pump at saturated liquid. Okay. So H5 will be saturated liquid. So 2230 minus H4 minus what is the value? 200. So what is the H4 we will get? 2430 kilojoule per kg. Okay. Now we have already got the enthalpy of here. Now it is they are directly asking the quality of the steam. So quality of the steam they are asking. So they have from the question they have already mentioned that the steam which will be coming out of the turbine 2 will be wet. So this we can directly calculate what is HF plus X4 to HG minus HF. 243 200 plus X4 to what is the HG? 2600. So calculate from 929 or in percentage 92.9, but they since they have asked next integer value, so you have to write answer in 93. Okay, hello, is
Yes, sir.
that fine?
Yes, sir.
Okay, wait, call is coming. Let's take this. Till the time you try to solve this next question, these other question, side and board.
So for the fifth problem, would the answer be 1512.95?
So I'll discuss. First, you let other people solve. Yeah. What is the answer of question number 3 which you have got?
4.
How much?
4.
Uh, how many you have got per kilowatt hour? I think it is a straightforward question. Uh, This second question actually came in gate 2021. This is it. So all the questions are of 2 marks, and this is for 1 mark. So we'll solve the question number 5. I've already mentioned that class that specific fuel consumption is given by 3600 upon net worth. Okay. So they have in the question they have mentioned that turbine work and pump work. What is the turbine work they have mentioned? 903 and pump work 3. Okay. So just put the values net worth 3600 divided by 0. So question number 4 we have already discussed in the class. What will be the answer?
C, sir.
C, sir.
Okay. Following ideal Lincoln cycle thermal steam turbine. So
Yes, sir.
answer C, right?
Sir, A is not correct.
No. We have already discussed now. Increasing the boiler pressure will you are saying the boiler pressure, na? We will increase the boiler pressure. Suppose this is the previous boiler pressure. So if we are not superheating the steam will all at that time also will remain in the wet region. Okay, this is the idle Rankine cycle. This is initial boiler pressure. This is final boiler pressure. So in idle Rankine cycle, the steam always enter as a saturated vapor, the form of saturated. So if we will increase the even though the pressure, so what will happen? The quality will decrease actually in this case. Previously, suppose this is the ideal one. 1, 2, 3, 4. Now 5. 1 dash 2 dash. What will happen at the if we are increasing the boiler pressure? So quality of the steam is not improving, it is degrading, it is becoming more wet. So what will happen? It will cause the corrosion and erosion of the turbine blade. So first and second will not improve. Third one is the increasing the turbine inlet temperature. So this can improve actually turbine inlet temperature. So by how many methods we can? First by superheating. First one, if we will increase the superheating, then we can improve the quality. This one, okay. So we are reducing. Or by second method by reheating. We will reheat. What will happen? Then also quality will improve. So these are the two methods by which inlet turbine temperature can uh, exit. The turbine temperature will improve. Temperature will improve. And, what will happen? Enthalpy will improve. H will improve. And consequently the quality. Okay. Hello.
Yes, sir.
Yes, sir.
Now do this question. Uh, So what is the answer you have got? Anyone has got the answer to this question? They have just answered the uh, turbine work. W plus W. What is the answer you are getting? Hello.
1513.
1513. Yeah, it is right. Because they have asked the question the round of the nearest integer. Anyone else who has got this answer? Should we do the question? Hello.
Yes, sir.
Should we do? Has anyone other else got the answer? 1530.
1512.95.
Yeah,
That's what I.
yeah. But in the question they have asked, na, round off to the nearest integer. So you have to. The answer will be
Okay.
1530. So they doesn't want the answer in the point. It is right. So I'll tell you. I will discuss this question. So for the superheated steam, first we will actually draw the diagram. What they have asked, given in question that in a steam power plant, superheated steam enters at 10 megapascal. So it is entering at 10 megapascal, and the quality of steam is superheated. It is then expanded isentropically in a turbine until it becomes saturated vapor. So this is point 1. Point 2 is saturated vapor. Okay. It is then reheated at constant pressure to 500. So they have already mentioned that the temperature for this is 500 degrees Celsius. So it is again reheated at constant pressure of the same 500 degrees. So 3 and 4. Now Telchin is next expanded isentropically in the turbine until it reaches the condenser pressure 20 megapascal. And the intermediate pressure they have also mentioned this one 1 megapascal. So relevant properties. So they have they want to know the total turbine. So WT1 plus WT2. Okay. From the table they have already given for saturated for superheated steam they have mentioned. So at 10 megapascal pressure, what will be the enthalpy of H1? H1 they have already mentioned from the table. We can write at 500 degrees Celsius and 10 megapascal pressure. Enthalpy will be of H1 3373.6 kJ. Okay. Similarly, for saturated steam, they have clearly mentioned that the steam after expanding in the turbine, first turbine, that is turbine 1, that is turbine 2. So after expanding first turbine, the quality of the steam is saturated. It is saturated vapor. So H2 will be equal to Hg at 1 megapascal pressure. Okay. So what is the value of Hg at 1 megapascal pressure? That we can get from saturated steam table at 1 megapascal. What will be 2778.1 joule per kg. Okay. Now point 3. Point 3 is again superheated, but here it is at 1 megapascal pressure because it is heated at constant pressure from 2 to 3, and point 2 is at 1 megapascal pressure. So quality of the steam from the superheated table we can get at 1 megapascal pressure and 500 degrees Celsius. What will be the S3 will be 3478.4. Also, here we can get the entropy because we don't know the quality of the steam at the exit of the turbine 2. Because in the first they have mentioned that it is saturated vapor, but in the second part they haven't mentioned that the after expanding in turbine 2, its quality is saturated vapor. They haven't mentioned that, so we have to determine the quality also first. So what will be the S3? S3 for superheated steam, we can get directly from table 7.76 per kilojoule per kg Kelvin. Now S4 we don't know, that we have to determine. Okay, so that will be in wet region or something. That for that we have to calculate the first dryness fraction. It will be less than 0 or 1, then it is in wet region. If it will equal to 1, then it will be saturated vapor. If it is greater than 1, then it will be superheated. Okay, so first we will determine that only. So since after the turbine 2 in steam is expanded in turbine 2 from 3 to 4. So for isentropic process, we can directly write S3 is equal to S4. Is it fine? Hello? 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 Am I
Yes,
audible?
sir.
Yes,
Yes,
sir.
sir.
So S3 we directly know from the table, that is 7621. And for 4, since we don't know, so we will first determine the value of X. So SF, and S4 we will determine at a condenser pressure of 20 megapascal. From properties we will take from 20 megapascal, because zero point 0.4 is it has a condenser pressure. So X into bracket Sg minus 77621. SF, what is the value of SF? Point 8319 plus X. X4 bracket Sg, what is the value of Sg? 7.985. What is the value of X4 we will get from here? You have already.
0.9793.
Okay, it is right. So this we will get. Now from here we can get the enthalpy, that is HF plus X4 into Hg minus HF. All the properties test we have to take from 20 megapascal condenser pressure. Okay, so H4, from here we can calculate what is the values. Point plus 0.79. What is the value of Hg? 609.7 minus 251. So what is the value of H4 we will get?
2560.89.
2560
89.
Okay, you can take 9 also, kilojoule per kg, or you can write 89. Okay. So and we have already determined all the 4 enthalpy, H1, H2, H3, H4. So directly we can write turbine work is equal to WT1 plus WT2. So what is the enthalpy of point 1? That is E7 3.6 minus what is the value of point 2? 2778.1 plus S3. What is the value of S3? 3478.4
3478.
minus what is the value of enthalpy? 2560.9. You can directly write. So what you will get turbine work? 1512.95. Since there was the question nearest integer, so the joule per kg. Okay, is it fine? Hello, anyone having doubt? Hello.
No,
No, sir.
No,
Okay.
sir.
So we next question. Please solve the next question. That is this one. Hello.
Yes, sir.
Yeah. You can solve this question.
Okay, sir. Okay, sir. Trying, sir.
three point six.
What is the answer you have got for the first question?
Three point six.
Three point six now. Yeah, 3.6 is anyone else who has got the answer?
Same, sir.
It is same. I think there is no need to solve this. I can solve it here only. It's specific to steam consumption, SFC, that you can directly 3600 on net work. So, it is captured. So in the steam power plant, uh, both they have mentioned so turbine working minus minus this will be turbine work minus pump work. Pump work entry exit at 121 currently at what is the value? So 1000. Okay, that's fine. Next question, you try to solve.
26.
Sir,
Okay.
26.
What is the answer for the question number 2 you have got?
Yes, sir. 26.01.
26.01, na? It is right. Anyone else who has got the same answer?
hello, sir. Sir,
Yeah.
in ideal Rankine cycle, the entry to the turbine is
It always,
dry saturated.
if it is not mentioned, you have to always take that it is saturated vapor. You have to always remember that if they are not mentioning any superheated reheated cycle, they are asking about ideal Rankine cycle, which always you have to entry will be saturated. Okay? This type of cycle you use.
Okay, sir.
This is the ideal Rankine cycle. Okay? 1, 2, 3, 4. The entry will always be saturated vapor. Indeed, that is Vg. And here at the entry of the pump, it will be saturated liquid. Okay. We'll try to solve this question. Actually, the question is simple, but you have to determine
3.71 kg kilowatt per hour.
what question number 1.
3.
Question number 3. Yeah, it is simple. You can do.
Answer is 3.71.
Yeah, it is. Okay, it is right. These all questions came for 2 marks. Look, just a simple calculation you have to easily get 2 marks. That's why at the starting I try to solve you 1 or 2 big question, because if from one question you can get the just for 3 or 4 to 5 uh, questions, objective type questions. So we'll do this question number 2. Whatever in the steam power plant operating on an ideal Rankine cycle, a superheated steam. No, and then steam power. They have mentioned here that it is superheated. If they have mentioned the superheated steam, then you have to take that. The person was asking this question only, na? That if it is no
Yes, sir.
if it is mentioned ideal Rankine cycle, then we have to always take saturated vapor. No, it is not right. Actually, when it is not mentioned anything, like the one in this question, they have mentioned that it is entering at in a superheated steam enters the turbine. So it is an idle cycle, but the entry they have actually mentioned. So it is a superheated vapor like this they have mentioned. But if they wouldn't have mentioned that condition that it is a superheated, they have only mentioned idle Rankine cycle. Then in that case, you have to just take this on that it is entering as saturated. Okay. If nothing is mentioned, then you have to consider that they are asking for this point only, that the entry point is saturated vapor. Vg. Okay.
Yes, sir.
If nothing is mentioned, then just consider that. If they are mentioned, then you have to calculate according to their. Okay. So what they have mentioned in this question, that superheated and superheated steam enters the turbine at 3 megawatt. So This pressure they have mentioned, boiler pressure 3 megapascal, and point this temperature at point they have mentioned what is 350 Celsius. Condenser pressure they have mentioned 72 Pascal. Okay, they want to know the efficiency. Okay, so data they have given for saturated liquid and pressure. Okay, so for point 3 we don't need to calculate anything because at the question they have already mentioned that at pressure of 3 megapascal and temperature 350 Celsius superheated steam is there, and for that they have already given the data, that is H1 they have given. What is H1? 311,513 kilojoule per kg. Similarly they have given S1 also, they have given 6.7428 per kg Kelvin. Okay. Now for point 2 we have to calculate it. Similarly point 3 then not mentioned. So we will take it as it is point by point. We will calculate first S1 equal to S2. We need to calculate the quality of the steam at the exit. Okay. What will we S1 they have already given 6.748. Okay, and S2 we have to determine it 75 kilopascal pressure because it is at a condenser pressure. Okay, so what will be SF plus X2 SG minus HF 6.7428 1.2 SFG they have given, that is the difference between that SFG. So in the question they have directly given SFG. So 6.24. So what is the value of X2 you have got? No? Can someone tell me?
0.885.
Yeah, 857, or you can take 0.886 because it is almost near. So any value is correct. So from here we can determine H2 HF plus X2 HFG. These all values we have to take it 70 from the stream table. So 4.962 8857 to what is the value of 786. So what is the H2 you have got?
2400.95.
2400 point.
95.
Okay. Now H1 H2 we have determined. Now we know that pump work is given by F into P boiler pressure minus P condenser pressure. Okay. So what is the value of VF at a 75 kilopascal pressure? 0.00107 to 3000. We have to convert into megapascal into kilopascal minus 75. So what we will get WP pump work. Hello.
3.
Yeah.
3.03.
And at the entry of the pump evaporator S3, it is equal to HR. It is in the form of saturated liquid. So what is its value? 384.09. So pump work is equals to H4 minus S3. So 3.0. H4 also we can get. H4 we get 7.4. So all the point enthalpy we have already got. Or pump work you can directly calculate from here. This will also work. Okay. I will just let you know how the enthalpy of other points can be determined. Okay. So because we need to calculate the efficiency. So what is the efficiency? Net work upon heat supplied. So net work will be H1 minus H2 divided by heat supplied will be H1 minus H4. Just put the values, you will get the answer. Because we have already got all the answer. Okay. So what is the answer you have got? 26.01%. Has everyone got? Because enthalpy at each and every point we have already got. Just we have to put the values here. Should I do that also or you can do? Hello? What is the value of enthalpy 1 which we have got?
3115.3.
5.3
3.
minus H2
2400.
400 divided by 30 minus H4. What is the value of H4 we have got? 387.423. Just put the value in. That you will get in point 5.2601, which since in the question they have asked in percentage, so just multiply it by 100, you will 6.01. What they have asked nearest value or just no. You have to write the answer in point also because they haven't mentioned anything. The thermal efficiency of the cycle is dash percentage, so you have to write the full answer 26.0. Okay. Hello. Hello.
Yes, sir.
Okay. What is the answer for the third you have got? 0.711 kg. I think this question already three, so I don't think need to discuss. Question number 4. What is the answer you have got? Hello.
Doing so.
Sir, fourth one, 40.73%.
Yeah, it is right. 40.73. Let others also solve. 0.7.
40.73.
Yeah, it is right. 40.7. Let others solve, then we will solve it.
Yes, sir.
Shall we do this question? We will do question number. All the data I think they have given, sir. Like was the temperature of the rate of the turbine is 500. Both the turbine is 500, and the test operating. It, one, five, six. So everything I think they have mentioned. This same temperature from point channel. Yes. Okay. It is it is from check. They have to in a Pascal, stem to Pascal. Okay. Value of point enthalpy at point 2 they have already mentioned in the question that H2 what they have given B185 at the exit of the first turbine they have mentioned. Okay, that is point 2 they have given. After that at the exit of the second turbine they have given H4 they have mentioned as that is 2 7 per okay. And H1 and S3 they have also given in the question itself. Here they have mentioned at superheated steam condition at 4 megapascal pressure, that is internal pressure. We are heating at constant pressure, so it's enthalpy they have given 3446, that is S3 they have given, and H1 at 8 megapascal pressure 3399 they have already. So all the enthalpy they have given. Okay. Enthalpy over they have also given H1 B H3 they have given B6 and enthalpy of the steam at the exit of the turbine. So there enthalpy of water exit of the pump 191, that is H6 they have mentioned. H6 also they have mentioned. It is 191. Now just we have to put the values. They have asked me enthalpy is net work on heat supply. So net work of turbine work plus turbine work 2. Okay. Because they haven't mentioned any properties at 10 kilopascal pressure, and also they haven't determined the value of H5. So they basically want that you should neglect that pump work because no properties are given. So just we have to neglect the pump work. It doesn't. It is given 0. Okay. So what is the turbine work? 13399 minus what is the value of H2 B185 plus H3, what is the value of H3 3446 minus H4 2247. So what is the value of we have got of net turbine work Hello?
1413.
1 kg per kg. Now heat supplied. What will be the heat supplied? It will be in the two cycle. One is H1 minus S6, and second is S3 minus S2. Okay. H1 minus S6 plus H3 minus H2. What is the enthalpy of 1? 3399 minus S6 191 plus S3 3446 minus H2 3185. What is the value you have got for the Q supply?
3469.
3469 kilojule per kg. Just put these values above here. What you get? 1413 divided by 69 is at what
0.407.
73 or what 2.7 percentage. Okay. Next question we will do. If it is not mentioned, I will directly give you the data. I will give you slide. Should form. Hello.
Yes, sir.
Sharing that question also. Yeah, I have already uploaded. So, and Priyanka has already. You can get the channel, subscribe, or but you can get all the lecture from that channel. Is my screen visible?
Yes, sir.
Yeah. Do this question. Is it visible? Check everybody.
Yes,
Yes.
sir.
Right. Here one thing is mentioned, please, adiabatic efficiency, or you can also call it isentropic efficiency, which we have already discussed in the gas turbine. So you might be remembering how to call it. And not something with the vowels and like some some components can this map.
Both are C.
Both are C.
Yes.
Yeah, let others solve it. Discuss.
Last part is the easiest one.
What?
49 is easiest one.
So on high. Exactly. The simplest method. So always, if you are confused, you will just subtract the lower subtract the divided by the Has anyone other for the answer?
First one is C.
Yeah, C is right. So second, first, first you have to calculate first after that.
C, sir. C. Both C.
I'll give you 2 or 3 more. Okay, I will start this. So, what this turbine with 4 megapascal pressure and 350 Celsius. Okay, and exited. So what they have mentioned that enthalpy of the entering steam HWR, it is not saturated, it's superheated. Was saturated, but they haven't mentioned anything. They have directly given the enthalpies. So uh, this is from the side because gravity this point can or cannot be outside there. So that we have to calculate first based on the 2s only. Determine. So this will take 2. So at the pressure of boiler pressure there for megapascal PV and condenser pressure of pascal. So at condition H1, what is the value of enthalpy? We have directly question.
090.
Hello.
3092.5.
What will the entropy also they have given?
6.58.
6.521.
5 okay. So since process 1 and 2s are isentropic process, isentropic process is 1 to 2 yes, 1 to 2 is not an isentropic process. In isentropic process, what exactly happens until that entropy remains same. So S1 will equal to S2S. From this, we can determine the quality of steam at the exit of the turbine. Okay. So what is the value of S1? 6.581, and for 2 SF, this we have to determine at 14 kilopascal per. So SF plus H2S G and H. SF and all those at low pressure
0.7549.
1549 H2S SG 8.005 minus. So What is the value of H2S which we will get?
0.803.
80. Okay, this we will get. Now we will determine the enthalpy of 0.2S. What we will how we can provide check plus H2S Hg minus HF. Because we have to put this. This all values we have to get 10 kilopascal pressure, 15. Okay, so 226.95. What is G? 599.1 minus 6.9. What is the value of H2S which you will get?
2132.
2132. Any other point?
75.
0.75. Okay. Now we can determine delta H isentropic, that is H1 minus H2S. What is the value of H1? It is directly given in the question. 9, 2, 5 minus H2S we have to 2.75. So what is the value we will get? Hello?
$959.75.
So now that is isentropic or adiabatic efficiencies for turbine only they are given. Turbine 0.95. What is the delta H actual, delta H isentropic? Okay, which is of the right H1 minus H2 divided by H2S. Okay, so 0.9 upon H2 and so 5. So what is the value of delta H actual which we will get? Can someone
864.
860. Similarly from here we can write, that's all we need. Okay, so this will be what delta H actual is equals to, is the turbine actual one. Okay, which will be equal to 864. Now we have to determine the pump work. What will be the pump work? We have entry to the pump is saturated vapor to the boiler pressure minus the condenser. Okay, what is the entry to the pump is
0.0014.
1.14.
0.14.
Yeah. And boiler
Minus 50.
boiler pressure is 4 megapascal, so we have to convert it into pascal by multiplying 1000 minus 50. So what is, we will get the pump work 4.04
4.0.
kilojoule per kg. Okay. So what will be the net work finally? Turbine work minus pump work. So 864 minus, directly we will write 4 only. So 860 kilojoule per kg. Okay. Is it fine? Now for the part 2 is much easy actually. Part 2 what they have asked actually they want to know the heats supplied to the cycle. We know that the pump work is given by H4 minus H3, so 4.04. H4 we don't know, H3 we know that entry to the pump is saturated liquid. So what is the value of H3? H3 will be is equals to HF at 15 kilopascal. Okay, so 4.04 H4 minus what is the value of this 226.95. So what is the H4 we will get? 230.99 kilojoule per kg. Or you can write H4 directly, 30 kilojoule. So now what we will get? We know that heat supplied. Q supplied will be H1 minus H4. From diagram we can get H1 minus H4 will be the heat supplied. So what is the value of H1? 3091. What we will get? Hello?
2861.
Wait, it's
2861.4 kilojoule per kg. This is
Great.
one of the answers. Which one it is closer? Is both or same. Okay. Hello.
yes, sir.
Okay. So that's all for today class. In the next class we will discuss about regeneration. We have covered all the numericals actually which they have asked from this part. Rankine cycle, simple Rankine cycle, reheating, superheating. So only part remaining for this cycle is I think that only regeneration part that we will do, and after that we will solve the problem for that also. Okay. I
Okay,
think
sir.
they will ask the problem up to this level only. I don't think they will ask anything much more.
Okay, sir.
Okay.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you. If anyone
Thank you,
is
sir.
having doubt, you can ask right now.
Still now have no problems, sir.
Okay. 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 Happy New Year to all.
Thank you, sir. Thank you.
Okay, then we'll end the class here only. We'll start the regeneration in the next class. And then once you try to solve the problem, because it is also there are many questions.
Okay. Thank you, sir.
Thank you.
Bye.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Hello, sir.
Yes.
Sir, while solving problems, I am requiring too much time, sir. What should I do, sir?
You have to do it by yourself only. Just do as many question practice as you can. So it will increase your speed. For that you have to just take time to watch and just put that I have to solve the problem at home. So then try to solve that. So only practice will make it. Because previously when I was giving also at that time also I was feeling the same problem came with me. But as I solved more and more problems, then automatically my speed. So the only solution I think is to solve more and more problems.
Okay, sir.
That will, because once you will solve the problem, you will encounter some problems might be similar which you are solving. Some problems will be difficult. So once you will solve a difficult problem, and then if the same problem comes after 2 or 3 questions, then it will become easy and you can solve it relatively fast. So solving more problems uh, by the topics related the topics you have read, that by solving problems only increase your skill. I think, or you can go for the test papers also, like online gate series. That they generally the question for a separate topic, like power plant. They will provide a separate topic wise question. From there, you can assess yourself.
From Gate Portal, sir.
Gate portal, not if you might have subscribed any gate series, gate test series. From
Yes, sir.
there you
Yes.
can get, or if you cannot get it from here, just take the book of the previous year gate questions and solve from there.
Yes, sir. Thank you, sir.
Thank you.